Hello everyone, welcome to Turbo Machines and in this video we are going to see the differences between impulse and reaction turbine. So now we are watching this steam turbines and all the definition part and compounding, pressure compounding, velocity compounding and pressure velocity compounding. So all these things that we have studied and now we will see the differences between impulse and reaction turbines. So let us move on to this slide. And this is the difference between impulse and reaction. So first one is the steam completely expands in the nozzle and its pressure remains constant during its flow through the blade passages. So what happens here is in the impulse turbine, as I have already informed that the main difference between impulse and reaction turbine is the steam comes and hits the turbine blades in a tangential direction as far as this impulse turbine is concerned. But whereas in the case of reaction turbine, so steam comes and hits in a radial direction. That means this turbine acts as a principle of a reaction with the help of this reaction. That's why it is called as a reaction turbine. So what happens here is in the impulse turbine, so there will be a nozzle in the beginning, and then so there will be moving blades, and then there is a fixed blades, and then again there will be moving blades. So this is the different stages of impulse turbine. So in the beginning, so there will be a nozzle, so which will maintain the pressure. And what happens here is in the nozzle, so the steam completely expands, and during this nozzle, the pressure remains constant throughout the blade passages. Whereas in the case of reaction turbine, the first it will expand partially, and then it will expand. Expansion takes place in the rotor blades, that is moving blades. So the next one is the relative velocity of the steam passing over the blade remains constant in the absence of friction. So what happens the relative velocity? Because in the nozzle, so in the absence of friction, so the blade remains constant. That means the relative velocity will remain constant. So there will not be any friction. There will be absence of friction. But whereas in the case of reaction turbine, the relative velocity of the steam passing over the blade increases as the steam expands while passing over the blade. So coming to this impulse turbine, the blades are symmetrical here and here the blades are asymmetrical. If you look at that, if the tangential direction, so the steam comes and hits at the center of the blade, so it will move in both the directions since it is a symmetrical shape. So both the and there is an absence of friction, so both the direction inlet and exit velocity will be same. But whereas in the case of this reaction turbine, so blades are asymmetrical. So this stator, the guide blades will be act as a nozzle, and the moving blades act as a rotor, and then these guide blades will act as a nozzle over here. And blades are not similar; it is in asymmetric shape. And the pressure on both sides of the moving blade is same. So both the sides. So this pressure will be same, but pressure on both sides of the moving blade is different here in reaction turbine. And coming to this power developed, for same power developed, the pressure drop is more. The number of stages required are less. Impulse turbine, so pressure drop is more. So in each and every stage there will be there will be drop in the pressure. So the stages are not required much. So stages will be less because a very less amount of power will be developed, and then pressure drop will take place inside. So that's why the stages will can be less. But for the same power developed, here pressure drop will be small. That's why more number of stages will be required for this reaction turbine. Now coming to this, the blade efficiency curve is less flat. You can see in this pressure velocity diagram. So the blade efficiency curve is less flat. The blade efficiency curve is more flat. That we will see in the pressure velocity diagram. Here the steam velocity is very high and therefore the speed of turbine is high. Velocity as well as speed will be very high in impulse turbine. Here the steam velocity is not very high and therefore the speed of the turbine is low. So we have seen this particular point we have seen in the hydraulic turbine. When I was explaining this impulse turbine, that is Pelton wheel, Kaplan turbine, and Francis turbine. See, Pelton will have very high head and it will rotate in a slow speed. Whereas in the case of this Francis turbine reaction turbine, it will be very fast and the velocity also will not be very high. So that is the reaction. The same thing will be applicable over here. The steam velocity is not very high and therefore the speed of the turbine is low. Now this is the diagram, schematic diagram of the differences which shows the impulse and reaction turbine. Okay, so here with the working principle you can see. At the same time, here the pressure velocity diagram also can be seen in the same diagram. So first one is impulse turbine. You can see the moving buckets, that is rotor, and there is a nozzle, the fixed blade, that is a nozzle. So here through fixed nozzle, steam comes and hits the turbine blades and then rotor rotates. Now coming to this, the download one, so the middle diagram. So the green color will be termed as fixed nozzles and the red color is termed as rotors. So steam moves through the fixed nozzle and hits the turbine blades, the rotor of the turbine blades, and then rotation takes place. You can see the rotation, how the rotation is taking place after hitting, after the expansion process takes place. And below that, you can see the pressure and velocity diagram. So if you look at the pressure is in blue color, so you can see there's a variation. The orange is velocity. So pressure at the beginning, before entering into this nozzle, it will be constant, and then after reaching at the nozzle outlet, so there will be a sudden drop because the velocity increases at that place. Because if you look at that nozzle outlet, that area will be more. Since the area is more, so there will be sudden drop in the pressure, and then immediately the velocity shoots up. So that is the reason. So you can see the velocity is moving high in the nozzle, at the exit of the nozzle. After that, after exit of the nozzle, the steam enters into the rotor, that is moving blades. When it hits the moving blades, there will be a rotation. So in that rotation, the pressure remains constant throughout. But what happens to the velocity? Velocity comes down since it is hitting the turbine blades and the turbine blades are rotating. Since there will be decrease in velocity, there is a drop in the velocity. Now coming to this reaction turbine, so there will be a rotor and then rotating nozzle. So here there is a rotating nozzle, and so then there is a stator. Stator is called as taken as a nozzle here. So through nozzle, steam enters, and then through it will go to the rotating nozzle, and then it will rotate. So there will be reaction takes place between the stator and the rotor because of that reaction principle. So this will rotate the shaft. So that's why it is called as a reaction turbine. Now coming to this pressure and velocity diagram, that graph. So look at the blue line, so which shows the pressure. So at the entrance of the nozzle, so it will be constant. The pressure remains constant. At the end, at the exit of the nozzle, suddenly there will be drop. Pressure drop takes place, and then it will move to the rotating nozzle or rotor. So during that there will be constant pressure, and then at the end of this there will be sudden decrease in the pressure. Whereas in the case of velocity, so at the time of nozzle there will be constant velocity, and then at the end of the nozzle, so there will be sudden rise in the velocity, and then moving blade, so there will be decrease in the velocity. When it hits the turbine blades and it is moving, there will be a drop in the velocity. So this is the working principle and the difference between the impulse and reaction turbine. Now in this diagram, so you can see clearly that impulse and the reaction turbines. So the right hand side you can see the impulse turbine. First we will see the impulse turbine, how does it work. So in the impulse turbine there will be impeller, and at the center there will be shaft, and then at the outer part of this impeller there will be series of blades or buckets are fixed, and there will be a fixed nozzle for impulse turbine, and the steam comes out through the nozzle and hits the turbine blades, and the turbine blades are connected to the runner, and then so these are called as a bucket. Okay, so once it hits the turbine blades it rotates, and so there will be rotary motion, and there will be a fixed nozzle, so which will be both the sides, there will be number of nozzles. There can be single nozzle and there can be multiple nozzles, so that is fixed. And then so it will be rotating, and the remaining steam will be collected in the tail race. So this is all about this impulse turbine. Now coming to this reaction turbine, so there will be runner, and here there will be stationary guide vanes will be there, stationary guide vanes, and inside there will be runner. So there will be one part will be guide vanes, which is stationary, which won't move, and the other part there will be runner. So inside the stationary guide vanes, so there will be runner, and here nozzle will be moving here. So here in the impulse turbine, nozzles are fixed, and here nozzle will be moving. So when the through the nozzle, so steam enters into the stationary guide vanes, where it will act as a guide blades or guide vanes. So from there, steam enters into the runner, and then the expansion process takes place. Due to that reaction, so there will be rotation in the blades, and then it will turn the shaft. So this is how the reaction turbine works. So this shows the difference between the impulse and reaction turbine, the schematic diagram, and the compounding that already we have explained here. So on this context, I would like to highlight this difference between this impulse and reaction turbine compounding. So in the impulse turbine, you can see there will be first nozzle, and then moving blades, and then fixed blades, and there will be moving blades, and the pressure velocity graph that is shown over here. At the same time, reaction turbine, so there will be fixed nozzle, and then there is a moving blade, and again there is a stator, and there is a moving blade. And look at the pressure there will be periodically decreasing, and then the velocity will increase, and then in the moving blade it will decrease, and again in the stator blades it will increase, and then moving blades it will decrease. So this is all about the compounding of this impulse and reaction turbine. So in this next video, so we'll solve some numericals so that we will understand better. So thank you for watching this video.